Imagine sitting on the shore of a massive lake covering the Missoula Valley and stretching 3,000 square miles in every direction. The water, enough to fill 2 Great Lakes, floods all but the tops of the tallest mountains in the western part of what is now Montana. Imagine a dam 7 statues of Liberty tall, made of crystalline blue ice. The dam fails, and the lake is gone in just a matter of days. This is the story of Glacial Lake Missoula and the catastrophic events shaping our landscape thousands of years ago. The echoes of those events can be heard today in the stories the rocks in the river tell those who are curious and who listen closely. This scene, 18,000 years ago, began when Glacial Lake Missoula was formed by a lobe of the Cordilleran ice sheet, 2,000 feet high and 30 miles long. The glacier, located at the Purcell Trench, a large valley at Sandpoint, Idaho, blocked the path of the Clark Fork River. As the water rose to the depth of 2,000 feet behind the giant dam, the lake embraced the flooded mountains with fjord-like arms. Those arms included the Bitterroot Valley to the south, the Flathead Valley to the north, and an eastern arm as far as Deer Lodge. The massive ice structure strained under the pressure of the backed-up water for a long time. The lake bed, composed of gravel and sediment, compressed under pressure. Quiet waters lapped on the beaches of the extensive and intricate coastline, and mountaintops peaked above the water's surface.
When we walk around Montana and we see the rocks around us, a geologist's job is to be very observant and pay attention to those rocks and learn to tell the story of the history of the landscape. And the history of Lake Missoula is a great example, piecing together these different pieces of evidence, these different rocks and landscape forms that individually didn't make a lot of sense until we put them all together, and then we learned this really amazing story.
The ice fields built slowly over the course of 200,000 years. The Purcell lobe formed the dam, backing up the river's water behind it. As the climate warmed toward the end of the Ice Age, the ice began to melt. What had taken 200,000 years to build took a mere 2,000 years to vanish. The rising water and melting ice reached a critical breaking point. Dripping, slippery ice chunks released their hold from the massive glacier where the dam met the mountain. Calved icebergs floated on the lake. The front of the gigantic ice chunks bobbed in the water, pushed by howling winds and waves. The calving action triggered extensive sloughing, known as rotational failure, which chewed into the spine of the ice dam. This action was so powerful that the enormous dam broke, releasing a torrent of water. Glacial Lake Missoula was gone.
So there's no question, using this rotational mechanism, that we could have started on the Montana side and eaten clear through the core of the dam and gone out the Idaho side. Once you get started downhill on the Idaho side, the dam it's gone, because now you're working downhill on ever thinner, weaker ice.
The calving of other glacial lobes in the lake launched thousands of icebergs in a navy that sailed the rushing river and piled up in narrow canyons. The grinding ice left echoes on the landscape at Rainbow Lake, Eddy Narrows, and other locations along the river's course. The rushing water tore through northern Idaho, eastern Washington, the Columbia River Gorge, Oregon's Willamette Valley, and finally released its fury into the Pacific Ocean at Astoria. Imagine this cataclysmic event draining the entire ancient lake in not years, not months, but only a few days. Torrents of water destroying everything in its path. The sound must have been deafening. At once, the waters receded and the dripping canyons were silent. Total devastation. Scoured land, cleaned of all organic matter, scarred with ripples frozen in time and drainages instantaneously reshaped. Amazingly, this ice dam break happened not just one isolated time, but at least 2 and maybe as many as 100 times. The Purcell Trench refilling with ice, backing up the river, and then draining as if a giant had pulled a stopper out of a bathtub. The impact of the discovery of Glacial Lake Missoula's repeated and rapid flooding has changed the way scientists like J. Harlan Bretz, up to current researchers today, view epic events around the world. These monumental events happened so long ago. How can we know about these huge floods? Even though Glacial Lake Missoula is gone, there are clues that the curious geological detectives have followed in the last 100 years to piece together the puzzle of this ancient lake bed and the events shaping our landscape.
Follow the clues yourself and find more evidence of this amazing phenomenon in your own backyard. As you explore, post your photos on Instagram with #Montana Natural History Center. Let's get started.